Okay, thank you to be here. I'm Robert, co-founder and in charge of markets and sales for Windler. So, few minutes for me to give you some messages, key points about Windler. So let's go. Windler innovates to disrupt the world of transportation by developing a solution, easier and greener, cheaper and faster air solutions. Uh, everybody knows the problem of transport. Windler can't wait. We must act rapidly with a sustainable and most efficient solution compared to the current solution. But also a realistic solution in terms of technology, but also in terms of business model. I mean, sustainable and reliable business model. Here is our solution, the X400. I would like to present it. So some key points for the solution. Here are the most features. You can see its size, big size, aircraft, autonomous aircraft, 600 kilogram of mass takeoff weight. Some key points, unmanned. We transport only material, industrial, medical, military equipment. No packs, no pilot, only equipment. Our technology is capable to transport 150 kilograms over 400 kilometers. Perfect for customers in cargo segment. This technology, lift and thrust, is powered by a hybrid electrical powertrain. So very good point for low carbon impact. Another point, safety, first mandatory in Windler. That means that our vehicle has been designed since the start to meet the highest level of certification. It's very important for the operation of our customers. This is a first flight solution for complex expeditions, for connecting hard-to-reach areas. Our cargo drone is able to connect and deliver supply in remote to any isolated locations. Here are some examples, offshore or onshore. We can deliver in the mountains, in the sea, on the ships, on floating wind turbines, farms, in field military operation. But this is a delivery solution, but by consequence, it's also a solution for observation, mapping, real-time imaging. Obviously, this is a B2B logistics solutions for our customer. I mean, we cover middle mile segment with express deliveries, intercity, or in hub to hub. And I would like to highlight also some benefits for and uses for our defense, our military operations. Clearly, we can connect the troops, we can supply the soldiers, and rapidly support our trucks and tanks being safer. Not only being greener and faster, but being safer. I know you like movies more than long pitches, so I would like to let's see. The X400 in action, in support to maintenance in offshore energy field. Normally there is a music, but This is a smart drone with artificial intelligence on board. We deliver and we go back. A word about the team. So Windler is not only the story of three guys, two senior aerospace managers and one expert. It's also a start of a young spin-off of Onera, working with robust industrial partners. So spin-off Onera means high quality and safety. And now it's time for me to finish. So let's change air cargo. So means civil we are, defense we are. So keep in touch if you want to change air cargo operations with us, to help us, to support us, to working with us, to finance the French constructor of cargo drone. The roadshow must go on to make it fly soon. So thank you very much.
Thank you, Robert. Biomass is a good presentation.
Yeah.
Perfect. I'll leave you the floor. Thank you.
Okay.
Okay, hello everyone. I am Alan Patterson. I am the co-founder of Beyond Math, and we are applying AI to solving problems in physics and simulating the physical world. So we're all hearing a huge amount in the media today about large language models. We call these foundational models. And that's because like one model can do multiple tasks. And if you believe the hype, they can do everything. But they are first and foremost language models. They can't calculate airflow velocity or surface pressure on an aircraft, or they can't calculate the radiation pattern from the antenna in your mobile phone. And that's because for these kinds of problems, words aren't enough. Mathematics is a choice of language in science and engineering. And so at Beyond Math, we are building foundational models of physics so that we can model, simulate, and predict the physical world. So in aerodynamics, we run simulations of the physics of our design. It's a supercomputing task. A single simulation can take from hours to days, even weeks to run. This quote here is actually from motorsport, but it's the same problem there. They're talking about getting a single two-car simulation down to 11.5 hours on 7,000 cores on AWS, 7,000 CPUs. That's the size of the computational problem we face. We still build physical models of our designs and test them in wind tunnels against real physics. Most often, the measurements we take in the wind tunnel don't correlate with the results we see from our simulation. So the entire design, test, and evaluation process is hugely inefficient. But with AI, or machine learning, it's already proving itself up to the task of solving highly complex, huge-scale computational problems. Not only that, it does so orders of magnitude faster. So when we talk about hours or days, we can be down to minutes and even seconds to run. AI is also very flexible. We can train our models on the physics so that it generates simulation data, but we can also incorporate measurements from the wind tunnel such that a simulation from an AI model can correlate more closely with the real world. So beyond math, we are building what we're calling a digital wind tunnel. It's a fully AI simulated wind tunnel. We, as a startup, we've started actually out in motorsport, and we're working with a Formula One team. They're great for us. You know, they're very fast turnaround. They spend very quickly, and they're also great validation. You know, these teams all own a supercomputer to run their simulations. They even build their own wind tunnels. So with our product, their aerodynamicists can upload a CAD model of their designs into our wind tunnel, and they get real-time results being calculated. The process is meshless, so they can move their design around in the wind tunnel. They can reconfigure it. They can even redesign, and the calculations are happening nearly interactively for the aerodynamic performance of their design. So, you know, we're not expecting people to get rid of CFD tools tomorrow or wind tunnels, but they can really quickly assess the aerodynamic impact of the designs, so they can run in seconds without running the full simulations and waiting a day for the results. To give you an idea of the speed up they're seeing, we validated against their data a couple of weeks ago. In a simulation they ran was 100 CPU hours. It ran in 43 seconds in our tool. And that 43 seconds they didn't have to wait for. It ran 400 frames of a dynamic transient simulation. So it was actually continually calculating as they did that. A bit about the company. We are a new startup we founded last year. The startup, the founding team are experienced. I've been in machine learning for 30 years. I've been through many startups, plenty of successful exits, thankfully, to the likes of Google, Amazon, Oracle. We raised $1.5 million in pre-seed funding last year. Our lead investor is Up Partners, who are invest in mobility and aerospace. They're a US VC. We're currently building a world-class AI team. So, and when I say that, I mean we are recruiting from Google DeepMind and some of the top institutions in the UK. So Imperial, Oxford. We're actually based in Cambridge. And our plan this year, you know, we are very much a pre-seed startup. So our plan is to build and validate the technology and with commercial validation from a partnership. So we started with one of the big Formula One teams. I can't say its name, but and we are also looking for a partner in aerospace. So if you are interested in what we're doing, or think you could collaborate on a development partnership, or you know someone who could, we'd be very happy to hear from you. So I'm here. I'm Alan. My head of business development, Rob, is just there. And we'll be around after this talk, and we'll be also going over to one of the networking events. Is at the museum later. So please come and chat to us then. I would love to hear from you, and thanks for your time.
Up next, Martina from Destinus.
Hello, everyone. So I'm Martina from Destinus. We're a company trying to revolutionize the aviation industry. I love traveling personally. I love going to new places, exotic places, different environments, cultures, and learning about the history. And I'm sure many of you share the same thing here as well. But there are two problems. One, the aviation industry contributes to 2.5% of carbon dioxide emissions. So I do feel a little bit of guilt when I go traveling. And two, the second problem is that it's pretty slow. I mean, going all the way to New Zealand would take me 30 hours and I think about 4 different flights. So we're trying to change this by doing non-stop flying extremely fast. So we're going to be flying up to the stratosphere, about 30 to 40 kilometers in altitude, and we're developing a new type of aircraft that is somewhat similar to a rocket, and it's going to be flying at hypersonic velocity, so that's 5 times the speed of sound, which means that you can get to anywhere in the world within about 4 hours. This is the goal. This is what we're developing. And the core to this is hydrogen. So why we chose hydrogen? First of all, it's an abundant source in the universe. About 75% of the mass of the universe is hydrogen. You can get it and produce it from splitting water into H2 and O. And if you do this with renewable energy sources, it's green in terms of the production. And when you combust it, there's no carbon dioxide emissions. So it's also green in the combustion side. You primarily get heat and water as the emissions. Of course, there's some NOx emissions as well, but that is something that normal airplanes have as well. So we will try to reduce that as much as possible. The other reason is that hydrogen is highly efficient. It's 3 times the energy efficiency compared to normal Jet A fuel that is used today. So it's really good for mobility applications when you want to go long ranges, including trucks or maritime or locomotives, as well as aviation. The design of this vehicle looks a little bit different than what you're used to when it comes to airplanes. You see that it has pretty small wings. That is when you fly at hypersonic velocities, you don't really need wings. You want to try to fly as efficiently as possible. So we're developing this type of shape to be able to have as efficient lift as possible. And we're looking at developing an aircraft for 400 passengers. So you see all the seats here. This is the long-term vision of the company. So that you can get all the way from where we are today to New Zealand in 4 hours. And a lot of these technologies we have to develop in-house. Some of them already exist, but our new thing is that we're introducing hydrogen to this. The company has been around for just about 2 years. We have raised 50 million in private capital so far, and we have raised about 12 million in public funding. We're now also generating revenues. We recently acquired a new company based in the Netherlands, which is building gas turbines for the energy sector. So the company is now going into the energy sector as well as other hydrogen mobility areas as well, so that we can fund our big vision. We are developing several technologies in-house, as I mentioned. We have so far flown 2 prototypes. So we have Destinus 1 over there, which is a 4-meter prototype based on this Wave Rider design concept that has been studied for a very, very long time in Europe, about 15 years in Europe, and hypersonic aircraft has been studied for longer than that. And we have also flown this Destinus 2 prototype. It's a 10-meter one, and they both flew at about 300 kilometers an hour. We're also setting up a test site in Switzerland, where we are testing now with gaseous hydrogen, and next year we're going to be testing with liquid hydrogen. And you can see some of the testing up here. And then we're testing some patented technologies, such as an active cooling system that we're using to cool down the leading edges of the vehicle as well, because you reach about 1,000 degrees Celsius when you fly at hypersonic speed. And this is the new design. This is the first time we're showing the new design of our next prototype here at the Paris Air Show. It's Destinus 3. It's a supersonic prototype that's going to fly on liquid hydrogen next year. So this is going to be the world's first, to our knowledge. Super exciting. If you want to take a look at it, we have our stand out at A8. It's right next to the big black box, the Renault box. So you can go there and check it out and see what it looks like. It's going to be flying with a General Electric engine, and then we are developing the afterburner in-house that will run on liquid hydrogen. And in terms of the future aircraft, this is the first one that we're looking to build. It's a 25-seater aircraft, about 40 meters in length. And it won't have the range as the 400-passenger aircraft will have in the future. But it will be able to take you all the way from Paris to New York in 1.5 hours. So anyone who has flown on the Concorde before, you would know that it's about 3.5 hours of a flight trip. So we're reducing that significantly by flying 2 to 3 times faster. And we are going to introduce this in the early 2030s. The team is 140 people. We are based in Switzerland, France, Spain, Germany, and recently the Netherlands with the company that we acquired. We have a lot of experts from the aerospace industry, so you see all the companies here where they're coming from, and also now experts from the energy sector as well, which we are entering into. And with that, thank you very much for listening to this presentation. And I want to also highlight that it's extremely important that everyone here, tries to challenge the future and tries to make the future a better place, because this is important for us. So we need to look at what is it that we can do to go step by step to make it better, regardless of how complex it is. If we go a step along the way, it's already a win. Okay, thank you, everyone.
That's the one? Okay. Okay, perfect. Super. So I'll leave you the floor. You can use this.
Okay, so hello everyone. I will introduce our company, so Hive Electric. So Hive Electric is a startup, was created in 2019 in Lille, in the north of France. So we are making cell designs. So we are expert in cell designs, in pack maker, and also in chemistry. So we make battery without critical materials as nickel, cobalt, or manganese that we can find in other battery. So about the team, so it's an international team with high-level team in energy. We develop also new technologies in the energy transitions, in the R&D lab for energy storage in all applications. So in aerospace, in the stationary storage, for example with solar panel, also with automotive. We are a major player in the energy transition with the new energy battery. So for the moment, currently, we use LFP technology. So it's a mature technology, and we can ensure with this safety, quality. But also, we are working on another technology in our R&D lab with solid states and metal ion. But this technology is not enough mature for the market, but we are working on it. And also, we develop prototype, pre-series, customized battery, so we are flexible. We can fit to any needs, and we also provide franchise and licenses for industrial, for example. So our concept and our DNA. So as I said, we ensure safety, sustainability, efficiency, and also recyclability. So for the current technology LFP, so lithium iron phosphate, we ensure 60 to 80% for recyclability. And for the future technology, we can ensure 90% of recyclability and without critical materials, as I said, without cobalt, nickel, or manganese, that this extraction is polluting for the environment. So we are developing the metal ion. So the metal ion use aluminum instead of lithium. So this technology able to increase the energy density, also for the infrastructure. So well-established production. For recycling, so as I said, we can reach up to 90% of recyclability, and also to be more competitive for the price and the market. So we can see that aluminum is more important and very increase the capacity. And also for the innovation, so we develop also in the R&D lab the all solid state battery, so metal ion and all solid state battery to increase the energy density. So to pass from 300 to 500, and so to increase the performance and the efficiency. We use so high voltage and capacity materials, improve safety and quality also, stability and service life to ensure a long time of durability for the cycle, and increase also the operating temperature. So the target, the objective is to develop in the future a technology without critical material to ensure safety and performance. So just to compare, to sum up, so we are currently here, so with the LFP technology, we have commercialized with this technology, and the objective, the target, is to ensure and to provide the metal ion and solid state technology to reach 90% of recyclability. About the team, so we are a small team, about 15 collaborators on June 2023. So 100% of engineers have scholarships of excellent class major, and with 6 nationalities. So our engineers are experts in chemistry, as I said, but also in automotive, in cell designs, in battery pack. So about the market, so the objective of Hive Electric is to have more notoriety and so to extend our file and our application to other market is what we are here for aerospace. So the market for aerospace has a huge opportunity. So we can see with the lithium battery and with these figures. So for example, so the aircraft battery market will grow over 7% in the next few years. So we have a huge potential to provide our battery pack inside this aircraft. So the customer profile for aerospatial is eVTOL, for example. We have also flying cab, helicopter, electric aircraft, and also any device in which we can find battery. So we can provide tailor-made battery and then provide the certification for this. And to conclude, so a small differentiation. So between the previous technology for aerospace and with our current technology, so the LFP. So our technology LFP ensure good performance and we increase the voltage, the capacity, but we decrease the weight. And we know that in aerospace, each kg is count. So it's important to reduce the weight, the dimension also of the pack, and there is no maintenance for the LFP technology. And to sum up, so Hive Electric ensure battery pack, cell designs in our R&D lab, and we make battery made in Europe without critical raw material, ensure safety and sustainability. So we are just there. So if you have more information, if you want more information or more detail, we are pleased to host you. Thank you for your attention.
Last year, I was flying back home on a Christmas break to my family, and at the last minute, my flight was delayed. And I'm sure that everyone here has probably experienced that. The flight was delayed because of technical reasons. Hi, I'm Ayomide, co-founder and CEO of Quicker Incorporated. A major airline spent $2.8 billion last year on maintenance costs. And when they are maintaining their aircraft, obviously the aircraft is down. Our plan at Quicker is to keep airplanes flying. And our purpose is to eliminate operational disruptions for aviation industry by 2030 in the aviation industry through predictive maintenance. At Quicker, we onboard sensor data, operational mission data, route information, maintenance records, supply chain data into our Quicker track system. And we use statistical analysis and deep learning models to get results for aircraft availability score, fleet readiness. And we use that to optimize data quality, part supply, and asset assignment maintenance. And in achieving this, we achieve cost efficiency, aircraft availability for the airline carrier, mission capabilities are improved. We improve their maintenance effectiveness, their staff efficiency, customer satisfaction is increased, and business executives are able to make faster decisions. And in that, we are able to help them to decrease part inventory and opportunity costs. Now, all this data is customer specific, and the results that are also obtained are also customer specific. Right now, we have been accepted into an accelerator program sponsored by the United States Air Force, and we're currently working outside the research lab in Rome. And our Quicker track system has been modeled to apply to both commercial and military applications. To give you a more background of what we do with the Quicker track system, on the right side is the is an F-16 fighter jet. And on the left side is something called a digital twin. A digital twin is a virtual representation of the F-16 fighter jet. Now, with our digital twin structure, we are able to actually see what parts of the aircraft are healthy, what parts of the aircraft are not healthy. In the aviation industry right now, the kind of model that is being run is corrective. So that means we wait until something breaks down before it is then worked on. But with quicker track system, we are introducing the predictive maintenance. And with the predictive maintenance, just like I mentioned, costs are cut, and um, customers are also better served, because when your planes are down, your customers cannot fly. And when your customers cannot fly, they are not happy. Our team right now has a combined experience of about 50 years in the aviation industry. And if you're happy to, if you have predictive maintenance needs for your company, please let us know, or we are at Hall 3A 116. Thank you so much.